Okay, this is a problem real similar to the last problem on the quiz, which basically gives us a new car cost of $32,000, and it depreciates to 70% of its original value in 4 years. And all of this, we're going to round our answers to 2 decimal places. So assume that depreciation is linear. What is the linear function that models the value of the car t years after purchase? Okay, so after 4 years, and there's a couple ways to figure this out. This just is the one that kind of makes sense to me. After 4 years, the car will lose 30% of its value. So 0.3 divided by 4, the 4 years, so I'm going to take that 30% and I'm going to divide it by 4 years. It's going to lose 0.05. So that divided by 4 is, so it's going to lose 7.5% of its value each year. So we start out, I'm going to use that number here, we start out with the original value, and then every year that $32,000 is going to lose 0.075 times t. So if we put in a t of 1 year, that'll give us the amount. Now I'm going to go ahead and multiply those two numbers, the 32,000 times 0.075 for my final version. And when I multiply them, I get 2,400 t. So each year, that car in the linear model is going to lose $2,400 in value. Okay, we're going to do the same thing, only with an exponential function. And the function is e to the kt. A is the initial price of the car. So find the value of the constant k. So what we need is we need to know how much the car is worth. Now, the problem tells us that it's going to lose 30% of its value in the first 4 years. So we know at t equals 4, the value is going to be 70% of the original price. So 32,000 times 0.7. That's going to be the value of the car at 4 years. When I do the multiplication, I get 22,400. So we have a point here. T equals 4, y equals 22,400. We can use that number to do what they ask, which is to figure out the k, the constant of depreciation in the exponential model. So after 4 years, our $32,000 car is going to be worth 22,400, but it did start out at 32,000 times e to the k, and the number of years for that value is 4. Again, I've got an exponential equation to solve. I'm going to do that doing some division. Now, I try to keep these numbers exact, and there's a little bit of reducing I can do with the zeros. When I reduced 224 over 320, I eventually, just by dividing by 2, I got down to 7 over 10. Or you could use 0.7 because it's exactly equal to 7/10. So I get 7 over 10 is equal to e to the 4k. Now I'm going to apply my logarithm to both sides. So that cancels out with my e. And I get k is equal to ln 7/10 divided by 4. And that is the exact answer. And they did want some of these in exact form. So that's my value for k. And now the last thing they want us to do is use the linear model and the exponential model to find the value of the car after 6 years. Let me just write the equation, though. So my value of the car is going to be 3,200 e to the ln. I'm going to use the 0.7 here, divided by 4 t. Okay, so my linear model was v of 6 is going to be $3,200 minus $2,400 down each year, and that's equal to 17,600. exponential model. Okay, so it's ln of 7.7 divided by 4 times 6. I'm going to put that in the calculator just so you can see it. Okay, so the second ln button will get you e to the x. And what was it? ln 0.7 divided by 4. I'm going to close that parentheses, divide by 4 times 6. It's going to do it in the proper order of operations. So, and that's a pretty close number to that 17,000. So 18,741.18. And we are done with this lesson. See you in class.